Matrix algebra along with determinants form a very important portion in higher mathematical studies. Like if we do not understand the concept of matrix, then it will not be possible to understand the concept of determinant. Similarly, few properties of determinant needs to be known so that matrix algebra can be understood with a clear concept. So, in fact, matrix and determinant, these two chapters form together a collection in such a way that one cannot be left out without the other. So, today we will start with matrix algebra. Before starting into the matrix algebra, first, as we have been discussing in the previous classes as well, we need to know what a matrix exactly looks like. A matrix is actually a rectangular presentation of symbols or numerical elements. They need to be arranged systematically in rows and columns. Also, it describes various aspects of a phenomenon which are interrelated in some manner, right? A very basic example. Please, you have to keep in mind that when you are writing a matrix, in that case, we have to give a bracket sign, right? In determinant, we will not be giving a bracket sign, but simply two straight lines parallel to each other, and in between them, the numbers or the elements will be written. Here you can see, as shown in the PPT, that we need to write the elements, that is 1, 2, 3, 4, which are numbers organized in the box within a third bracket. At few cases, in few books or in few illustrations, you will find that instead of the square or rectangular box brackets, it also is given in normal simple round brackets. That also represents the denotion for matrix. Okay, now we are considering two linear equations in x, y, z. Now, from the first equation, we can find that the coefficients of x, y, z are 2, minus 3 and 1. And for the second one, it is 4, 5 and minus 3. Now, if I want to write the two equations, that is equation 1 and 2, in form of a matrix, then I will write in this form. That is, for the first row is the first row line, we are having 2, minus 3, 1, that is the consecutive coefficients of x, y and z. See, in equation 1, the coefficient of x is 2, that of y is minus 3 and that of z is 1. Similarly, for equation 2, it is 4, 5 and minus 3. So, this particular matrix, that is 2, minus 3, 1 and 4, 5, minus 3 is the coefficient matrix of equation 1 and 2. Please see that here I have mentioned something which is 2 cross 3 matrix. What does 2 cross 3 matrix means? The first thing that is written here, 2, denotes the number of rows. Rows, we write it in the form of horizontal lines. So here, two horizontal lines are maintained. 2, minus 3, 1 is the first horizontal line. The second one being 4, 5 and minus 3. So there are two rows. Similarly, we have three columns. What does column mean? The vertical lines, that is 2, 4 is the first column, minus 3, 5 is the second one, and the third column being 1 and minus 3. So it's a 2 cross 3 matrix. Now, we can have just a single element also in a matrix. Supposedly, I can say that 2 and I give a bracket. So, 2 means there is a single row and a single column. But since I have written it inside a bracket, it represents a matrix and it is a single entry matrix. Now, Here you can see there are several numbers. First row comprises of 28, 39, 57, 17, etc. till 18. That is the first row. The first column being vertically 28, 74, 88. Similarly, last element of the column is 34. So here we have got several such rows and columns. So this can also form a matrix. Okay. Now, as we have to go by the bookish definition also at times, here is a simple definition of matrix, which states that a matrix is a rectangular array of numbers arranged in rows and columns, enclosed by a pair of brackets and subject to certain rules of presentation that we will get to know as we proceed in the chapter. Okay, now see, as I mentioned that in case of determinant, similar representation of the second data set that is given here. Here we are seeing that two such lines are there. But if we had given one such single line, that would have represented a determinant. And as I already stated that a square bracket which already defines a matrix is always given for a matrix denotion. Few more interesting things to note down is that matrix is denoted by a capital letter. Like, I need to say that if I had to represent the particular matrix given over here, I would have had to written a capital A instead of a small a. This you have to keep in mind. Next is that the elements inside the matrix need to be written in small letters. Like, instead of 2 minus 3, 1, if I had alphabets written here like A, D, F, they would have been written in small letters, not in capital letters. Similarly, the number of rows and columns determined by M and N should be represented by small m and small n. As an example of this one, 2 cross 3, we could have written small m cross n where m is 2 and n is 3. But the M and N should be in small letter, not capital letter. So, this you have to keep in mind. Here is a general denotion of a matrix. Please all of you look to the PPT given over here. A matrix having M for Mumbai number of rows and N for Nagpur number of columns can be written in the following form. How is it written? See, first row is A11. Second element of the first row is A12, third is A1J and last being A1N. Over here J and N can be any numbers as permitted in the question. Like I could have had say 7 elements in the first row. Then I would have had A11, A12, A13, A14, A15, A16 and the last will be A17, that is n is equal to 7. So 7 columns will be there in all together. Similarly, look at the last row. The last row I have written here AM1, AM2, AMJ, AMN. If I had 6 such rows, then how would I have explained it? Please look to the first column. What would have been there? A11, A21, A31, A41, A51 and A61. That would have been the first column. Since 6 such rows are there, so 61 will be the last element present in the column. Similarly, if we traverse across the row, we would have had A61, 62, 63, 64, 65, 66 and 67 since 7 such columns are there. So, we would have had a 6 cross 7 matrix in this form, right? Okay, now we come to different types of matrices. The very first one being a square matrix. Very simple, the number of rows need to be equal to the number of columns. That is, if there are 2 rows, there should be 2 columns exactly. We cannot have a 2 cross 3 in a square matrix. It needs to be either 2 cross 2, 3 cross 3, 4 cross 4 or any such numbers. Here is the example. M is the number of rows and n is the number of columns. M needs to be equal to n so that we get a square matrix. Next, we come to the next set of matrix, that is a row matrix. A row matrix means we will have a single row. There will be numerous columns. Why columns? Because A itself represents one column. B represents another column. C represents another. D represents another. But row wise we have a single row present in the first horizontal line. So we have a single row matrix present over here. Similarly, a column matrix will be just a single column. There will be many rows. Like here we have 3 rows. A11 represents one row. A21 represents another row. A31 represents a third row. But column wise it is just a single one. Right? Next we come across to the next sort of matrix, that is the diagonal matrix. Diagonal matrix needs to be a square matrix firstly. That is, number of rows should always be equal to the number of columns when we are discussing regarding a diagonal matrix. Only exception is what? That the leading diagonal over here, A11, A22, A33, ANN, they need to be a non-zero element. Otherwise, all the other elements present in the matrix will be 0. Hence, we can say that this is a diagonal matrix. Right? Next, very important one. This we will be using in several sums. Only the denotion will be given over here, but obviously we need to understand what it means. A small rectification needs to be done over here. In the example, it is written I4. It will be I3 exactly. Why is it I3? Let me explain. See, here again, it is a square matrix, right? How many number of rows and columns? Please tell me. We are right. 3 rows and 3 columns. Since the number of rows is equal to the number of columns, therefore, here it is a 3 cross 3 matrix. Now, a 3 cross 3 matrix can also be written in just the form 3, that is I3. What is the denotion of I3? It is a diagonal matrix, that is all the elements other than the diagonal, principal diagonal is 0, but given that the diagonal, principal diagonal, the elements are nothing but 1. It needs to be plus 1. See here, all the elements in the diagonal is 1, all the other elements is 0. So this is a unit matrix of third order, right? So please make a rectification over here. This is not I4, this will be I3. Okay, next what we come here is a zero matrix or a null matrix. What do we mean by a zero matrix or a null matrix? Okay. Again, we have to discuss regarding a matrix which is in general a square matrix, right? All the elements will be 0. There will be no other elements, like there will be no 1s, no 2s, no -1, no -3, nothing. Everything is 0. So this will be represented as a null matrix. Okay. Next we come across another vital point, that is a triangular matrix. What is a triangular matrix? A matrix where the elements are 0 according to the superiority of the order of their rows m and n is called a triangular matrix. Now this seems to be really a tricky one if we go by the bookish language. Let me just give you an example of it to make you understand what it exactly means. Okay. Here see, we have a m cross n matrix. The principal diagonal is 1, 1, 2, 2, aij, amn. This is the principal diagonal. All the elements present above the principal diagonal are non-zero, and all the elements present below the principal diagonal are 0. So, if the order of row is greater than the order of the column of an element 0, then it is called the upper triangular matrix. Here see, all the elements present in the lower half is 0, and the other half, maybe few elements are 0 but not all. So this is a upper triangular matrix. Similarly, a lower triangular matrix will be what? The lower half will be non-zero, whereas the upper half will be 0. So this is a lower rectangular matrix. Now, if we have a 3 cross 3 matrix, which is the first one, 3, 1, 2, 2, 3, 1, 3, 2, 1. I'm going row wise. I take few elements from this and have another matrix 2 cross 2, that is 3, 1, 2, 1. So this represents a submatrix, right? Next, we come across to scalar matrix. Okay, what do we mean by scalar matrix? In fact, actually, it is a scalar multiplication. We take a square matrix, anything we can take in form of any such thing. Now we simply multiply a particular scalar with all the elements present in the matrix. So then we say that it is a scalar matrix. As an example, a square matrix when given in the form of a scalar multiplication to an identity or a unit matrix, it is called the scalar matrix. We all know that a scalar matrix or a unit matrix, I mean to say a unit matrix of the order 2 cross 2 will be 1, 0, 0, 1, right? Now if I multiply A to it, A will be multiplied to all the rows and all the columns. Since multiplying any scalar with 0 gives us 0, so obviously the second term in the first row and the first term in the second row are 0. But since we have 1 and 1 in the principal diagonal, they will be multiplied with the scalar A, and we have A0, 0A as the scalar matrix. We can also say a diagonal matrix is all diagonal elements are equal is called a scalar matrix. Right? Here you can see diagonal matrix 0, 0 is present in all the other elements other than the principal diagonal, and the principal diagonal both the elements are A, so we can say it's a scalar matrix as well. Okay. Now again in question they will not mention that what is a symmetric matrix. They will simply say that let A be a symmetric matrix. We need to know what a symmetric matrix means. Okay. We consider a square matrix A of the form Aij, where obviously I and j are your number of rows and j is number of columns we are considering, and aij are any such elements from ith row and jth column we are considering, right? Now for each I and j, if aij is equal to aji, we say that the matrix is a symmetric matrix. How do we explain that? Please look into the example of this. See, if we consider the first element 5, right? It is A11. So obviously this is a case of aii. But we are considering only aij's and ji's. That is, I and j are not equal. So the principal diagonal is left out, right? 5, 6 and 5 is left out. Now, where do we come across? We come across the second element of the first row. Second element of the first row. What is that element known as? It is known as A12. Over here, please see A12 is equal to the number 2. Similarly, when we come to the second row, its first element is A21 that is also 2. So here we see A12 is 2. Again A21 is 2. So A12 is equal to A21. Hence, we see that over here it follows the pattern of symmetric matrix. That is, Aij is equal to Aj. Please observe for the other elements as well. Over here you will see all of them following the same norm. That is, when we consider A13 and 31, that is the third element of the first row and the first element of the third row, both of them are 1. So A13 is equal to A31. Similarly, the third element of the second row is minus 1, and the second element of the third row is again minus 1. So A23 and A32 are equal. Hence, it is following all the properties of symmetric matrix. Right? Next, we come to the complex conjugate of a matrix. In general, most of our universities or boards do not deal with this particular thing, but just for your information purpose, since we are all dealing with real numbers, so complex numbers doesn't come into existence for the time being, but for your knowledge you can go in through the reference of this one. That is, here we are considering the complex conjugate as A and A dashed. Right? You can see in the example and you will very well understand what does it mean. Okay, now we come to skew symmetric matrix. Just keep one thing in mind. Skew symmetric matrix has the same property as a symmetric matrix. Only one thing you have to keep in mind is that Aij is equal to minus Aj. Right? As an example over here you had Aij is equal to Aj. Here we will have Aij equal to minus Aj. Also, in a skew symmetric matrix, the primary or the principal diagonal will be 0. So please see here, the second element of the first row is minus 6. The first element of the second row is plus 6. So here A12 is equal to minus A21. Right? So this is the property of skew symmetric matrix. So that's it for today. We have done a brief discussion regarding the different types of matrix. In the next class, please do follow. We will be discussing regarding the different